learned what GIS is all about, what GIS can do, and we learned the basics. So I shared the material already on the group. If you have not read it, you can please go over it. This is the material, right? We talked about GIS, Geographic Information System. It learns that um, we learned the understanding of GIS and how it works. We learned about collecting, managing, and visualizing data. And we learned about introduction to GIS analysis, all right, on and the theoretical part, and we could not get to the analysis yesterday. Then we learned how that we learned the definition of the terms, and I explained every of it in depth, right? So we are working on uploading the recording to a central page where all of us can have access to. So by Monday, our IT officer has promised that latest by Tuesday morning, the link will be available to all of us to watch, right? So to access. So please bear with us for the meantime. We don't want to start sending it one after the other to everyone. So we are just going to put it on a platform so that everybody can have access to from there. So of course, we have components in GIS. We learned about hardware, which are the people. We learned about the hardware are the devices we use. We learned about the software. We learned about data methods and people. Yesterday, I was explaining that most of us, when we hear GIS, we think it's just the software, ArcGIS, QGIS, ArcGISPro, MV, and all that. But yeah, software is just a part, an aspect of GIS. Then we learned about data, so that we have different type of data. We have spatial data, we have attribute data, we have vector, we have raster, right? So um, so processes and workflow, which is the method and the people. Then how it works, combines layers. Just please go through these notes. Please go through these notes. Go through these notes. Go through these notes, and that will be it. So this is an overview of the three softwares we are supposed to learn in this training. All right, and getting started with this software. Is out to the link to download the one that is open source, and of course, ArcMap is part of the ArcGIS tool, ArcGIS desktop suite, and which is the older generation. Right now, Esri has moved on to ArcGIS Pro. I'll show us what ArcGIS Pro looks like today, no matter how little. Our focus will be on QGIS, and we'll finish what we were doing yesterday. So, excuse me, please. So, I've talked about data, vector, raster, attributes, and all of that. So, basically, we studied ArcMap yesterday, and we did all of these things. We added data. Okay, I didn't show us symbology. I showed us attribute table, labeling, then layout. These are the things that are possible with ArcMap, and we started the process yesterday. I'll do an overview after now, then the basic analysis we can do and explain what we mean by buffering, what we mean by clipping, intersect, spatial joining, and all that, right? So today we are going to be focusing on basic operations in QGIS, and then we'll learn, if you have time, basic analysis. Then we'll learn basic operations in ArcGIS Pro and the basic analysis, right? And this is the assignment that's been given to you guys to do. So like we said, the criteria for certificate is your attendance. You have to at least meet if you have attended FSS. I don't know if you guys have it in like you have what even where I did my postgraduate studies here at the University of Nigeria, there's a man that insisted on 80% attendance, and it wasn't joking. We thought he was joking. We thought he was joking. So yeah, for you to be eligible for this certificate, you have to get up to up to 70% attendance, and you must push in the 2 assignments that has been given on or before the deadline that will be stated. I think we'll just give you 2 weeks after this training, which is ending today. We'll give you 2 weeks, which is 2 Saturdays from now. Once you don't roll in, your assignment is not with us. That means you're not eligible for the assignment for the certificate. So we have 2 assignments I'm expecting. The first one is from AutoCAD and Sofa, and the second one is from ArcGIS, ArcMap specifically. So you can use ArcMap, you can use QGIS, you can use ArcGISPro. Just give me what I asked for in this assignment. That's what I'm after. So since we are going to teach you like 3 softwares, you can choose which other one. All right. So this was how we ended yesterday. So like I said, let me just quickly like give you a recap on what we did on um, ArcMap yesterday. So this is the ArcMap environment. This is the ArcMap environment. For you guys that were not around yesterday, so I'm doing this recap because of you. But if you think you know these things already, please just unmute and let me know. Tell me to go ahead or to continue the recap. So please let me hear from you. If you think the recap is necessary, let me know so that I can quickly do something for you. But if you think you are past this stage, just let me know so that we can continue. Still have a lot to do today, yeah. So guys, on mute, don't be silent on me. Don't be shy. Don't be shy. Don't be shy. Okay, Bolu Atife on mute. Bolu, you know I always call you on mute. And tell me. Ashokwe, I didn't get you. Okay, just type it in the message. Type it on the message box. Type it on the message box since I can't hear you. Sheriff, should go ahead with the recap.
Yes, we can go ahead with the recap.
All right. Jibril, 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 I want to hear your voice. Should we go ahead with the recap? Demilade, are you there? I just unmute and say yes or no. You don't have to say too many things, right?
Hello, good morning.
Good morning.
Yeah.
I'm asking if you think we should go ahead with the recap.
Yes, we can.
All right, thank you. So, going over what we did yesterday. So we started by our end result. What we want to achieve is that we want to take a raster data, and I explained yesterday what the raster data is. Raster data is a data that appears in form of images. So you will not literally say images, but you can say that they appear in form of pixels. So every image appear in pixels. So if you're seeing my screen right now, you can see the small boxes that appears on the screen. Those are pixels, right? So it is these small boxes that makes up every image that you see. So the bigger, the higher the resolution, the smaller the boxes. The smaller the boxes, the smoother your image looks, right? So if this was a more higher resolution, the boxes will not be as big as this, right? So raster data are represented in pixels, and vector data. There's no S at the back of data. Vector data are represented in line, points, and polygon. Line, points, and polygon. So what we want to do is convert this raster data into a vector data, and we were on the process, right? So we've started conversion. This is like the road you were seeing, no, the river you were seeing on the raster data. This is like the river. So you have started converting. If you see the river on the raster without the vector there, you see that it is represented in pixels, right? So we want to convert these pixels just to a line, just to a line. So we are trying to convert raster, and for us to do that, we have to like get our raster data. So if you check the document I sent, you see various ways of acquiring data. We are doing remote sensing at the which course is that? They'll teach you that you have direct um, method of acquiring data, which is your field survey, either by drone, either by GPS, either by tape and compass, whatever means you use. Is direct because you are right there on the site. And we have indirect. That will be our imageries, Google Earth imageries, Landsat, OSM and the likes. So those are indirect. So we had to like settle for indirect source of data yesterday, and we went to our Google Earth Pro. Went to our Google Earth Pro. We searched for the University of Lagos. We searched for the University of Lagos, and we mapped out areas around our sports complex. So our focus yesterday was the sports complex. We mapped out areas, and for us to be able to convert our raster data to vector, we had to select 4 control points. We had to select minimum of 4 control points. So depending on the accuracy you want to get, you can have more than 4. You can have 10. You can have 20, as you have the luxury of time to do that. So you should have minimum of 4 control, and we didn't just have the control points. We had to like write out the coordinates of the control. If you are a survey student, that I believe that you are, you would agree with me that for you to call someone somewhere a control, it means that it is in situ, and you have the identity of that point. The point is in situ, and you have identity of that point. So we have to like write out the XY. We do not need the Z, the value for this process. So after writing out the X and Y on a notepad, we went straight. Okay, so we had to like download this document. We had to like download this data. We converted it to extracted it from Google Earth, and converted it to an image, right? So we had to uncheck all of this. If you leave it checked, it means you'll be having a lot of writings on your map. All right, so we had to like leave it, uncheck all of it, then get out of map options, then come to resolution, click the maximum. Right, before you get there, just come to save image. So save image will, okay, let's just try it. So save image will give me all of these options. I will uncheck all of this and come to maximum resolution. Then I'll click on save image. It will save the image. It will tell me to identify the file I want to save it to, and it will show save the image. I will carry the image, right? Take the image straight, take it to ArcMap. Take the image, take it straight to ArcMap. When you get to ArcMap, what you want to do is you want to come to this place, add data. You want to come to add data. All right, you can also add data from here. So come to add data, go to where you have saved your file. So yesterday, this is the image we used. We have saved it already. So we will navigate to where we save, then click on the image, click on add. So once you click on add, it will come like this, tell you that the image is lacking spatial reference, and we know that's why we want to convert it. So because it's lacking spatial reference, you have to like assign real earth coordinate system to the image, and to do that we have to georeference. Georeferencing is just a process of assigning coordinates to a picture, to a data, so that it can have real life coordinates. Instead of attaching the coordinates one by one, we can spatially distribute controls around the image, and georeference it with those controls, and every other point we have their coordinates in that. So if you look at this part of the screen, you can see the coordinate um of everywhere on this image right now, because we have georeferenced. So we did the process of georeferencing yesterday. So For you to georeference, just come to this free tab. If the georeferencing tab is not enabled on your screen, just right click and look for georeferencing. Look for georeferencing. Toggle it on. Once it's on, then you click on add control point. Click on add control point and you select the controls one by one. So I told you yesterday that you will left click. So say I click on add control point, I will left click, then right click. So once I right click, it will it will it will it will tell me to add X and Y. I will add the X and Y that I had already put on my notepad and click OK. I will repeat the process for 1, 2, 3, 4. So if you can see, this is what we did yesterday. This was the initial point. Oh, this was the initial point. The green is the initial point, the red is the current point, and that was how the software adjusted the image to place it on the right position and attached spatial reference onto all the points. Are we good to this point, everyone? So if you don't want to unmute, as we always do, you can just put a thumbs up, use an emoji just to, so that I'm sure that you're following. So are we good to this point? Are we good to this point, guys? I'm sure you guys can hear me, right? So are we good to this point? Can you guys hear me? Okay, I'm waiting for you to respond. Can you guys hear me? Okay, Jane Jacob can hear me. Oh, all right. Okay. So it means we are following. We are good to this point. Yeah, so right from there, we move ahead to creating a file geodatabase. To create file geodatabase, you come to the folder you want to save your document, or the folder you're saving your document, and right click, go to new, and click on file geodatabase. File, I explained yesterday that file geodatabase is always public, while a personal geodatabase is somewhat private. If you want to give everybody that wants to access your job permission before they can, you use personal geodatabase to ask you to set up security for your database, right? So so we created file geodatabase, and this is the result. We renamed it as Unilag. And under file geodatabase, you right click again and go to new. Then you click on feature class. Feature class is the objects what we want to represent, use to represent each of the details on this map. So there are a lot of details on this map. There are vehicles, there are houses, there are offices, there are roads, there are rivers, there are grasses, there are trees. A lot of details are on this image, right? But what we need to do is to focus on what you want to achieve. So if this is a street guard map, I will not need to be picking trees. Do you understand? If this is a street guard map, I might just represent my images as a dot, as a point. Do you understand? But if it's an image I want to use to analyze settlement, something around settlement, or probably know what is affecting an area, I have to like represent my buildings as polygons, because um, um, buildings now have more interest to me than others, right? So, I mean, I'm saying that your future classes will be created based on what you want to achieve with your map. So yesterday we created few feature classes. We created buildings, we created river, and we created roads. So and I've outlined what I expect that you have on your outline what I expect that you have on your assignment in the document. So please check through that. So you create your future class, Once you're done with it, you come to editor, you click on start editor. So editor will ask you which of the spatial feature class you want to create first. So I can say buildings. I'll click continue. So buildings will not toggle my editor on automatically. So I would have to come to create features. So if you don't see it outside here, this is just the button. This is just a button. It's a feature under the editor tab, right? So I'll click on buildings. So I want to georeference buildings. And since building is not like a key thing I need on this project, so I've decided to use point to represent my building. So I'll just click here, click here, click here. So on every building I see, I'm giving it a point. So the point is telling me that anytime I see a point, I know that there is a building there, and that is how it will come up on my legend, right? So when you're digitizing, you have to be creative with it so that you don't confuse yourself. Know how to do it. If you want to do it clockwise, if you want to do it anti-clockwise, you just know your movement so that you know the areas you have done, the areas you have not done. So I mean, say I've digitized all the buildings. Yeah, I'll just go back to editor, save edits, and I'll stop editing. So once I stop editing, I can like view what I've done. So see how many buildings I've digitized. So I mean, this is the same process you will repeat for roads, for rivers, for trees, for whatever features you are interested in on this image. I think we are good to this point. So basically, so once you're done with this, say we have digitized everything and we want to okay, so let me get away with this thing. Okay. So this is the georeferencing. It's apparent there because I took it up. So say we are done with everything, we have digitized and all. So we can just go to Ooh, thank you, Jesus. Thank you for fighting my battles for me, Jehovah. So you can come to the layout view. Can come to the layout view. You can toggle this one off. Come to layout view. So for you to have a good view, right? Uh, for you to have a good view, you need to like zoom your map to a preferred uh, scale before you put it there. So yeah, this is our layout. This is where you now start inserting. You insert legend, insert title page. This is where you design your output, right? So basically that is what we learned yesterday. So and that is what I expect. This is the last thing that you do, which is your presentation. After you've done data acquisition, which we did on Google Earth, we did processing, the process of georeferencing and all that. Digitizing is still processing, converting from raster to vector, and then we moved to analysis. So say we are doing buffering, clipping, all of those analysis, then the final thing we'll do is presentation. Presentation is now what you do on your layout. Don't forget this is where to toggle it on or off. So that is that about ArcMap. I would take questions again before we move to QGIS. So if you have a question, please you can unmute or drop it in the chat box. If I wait a minute, I'll assume there is no question and I'll proceed. If you have a question, please ask in the chat box or you can just unmute and let me hear you. Questions, please. Questions, please. Questions, please. Questions, please. Questions, please. Um. Okay. Okay. All right. So, if there are no questions, let us move ahead to what we have to do today. Um. So, guys, we are moving on to QGIS, and I'll be sharing my screen again. Entire screen. Okay, so for QGIS, we'll be starting from where we stopped yesterday. And I will assume with the recap I just did that you all have an understanding of how to get your imagery from Google Earth Pro. So we assume that we have our image already. So we assume that we have our imagery already, and so I think I'll just close this. I'll discard it. No, discard. All right, and that will, okay, let me share my full screen so that I can follow entirely. Okay, so this is QGIS. You can see my screen. This is QGIS, and it's like the pack. These are the stuff that came with it, and we just open QGIS. That is not okay. So, like I was saying, we'll assume that we have downloaded our data because we did yesterday. So we'll be using the same image that we used yesterday, and that will be it. That is the folder that we'll be using. This is the folder that we'll be using, and yeah. So QGIS is loading, guys. QGIS is loading. Let's be patient. Okay, so QGIS have loaded, and this is the QGIS interface. We have the title page, we have the ribbon. The ribbon is always where you find your tools, the tools that you're going to be using, right? So for project, you can just explore the options there. For project, for edit, view. View always talks about um your your mapping area where you map, zooming, panning, and all that. Then another important part is the layer. So georeferencer is on that layer here. Maybe in previous versions or recent versions, you find it under raster too. All right, so that's layer. You can create layer here, you can add layer here, you can this is where you toggle your editing and all that, right? So as for layer, then settings, we have plugins. So plugins is where you can like add other extensions like Python, like other coding softwares. You can add, can connect GitHub, you can connect a lot of other extensions to Arc QGIS, and they work perfectly well. So vector, if you want to make analysis on your vector, this is exactly where you come to. So buffering, clipping, all of these, the analysis of vectors are all here. Then on raster, you have the analysis we can make on raster, on our raster data. Yeah, right. So yeah, database where mesh, we are working on the mesh to do a lot of benefit. Then you have the processing. This is the toolbox. I told you yesterday on ArcGIS, ArcMap, that toolbox is Very important. And then Yoruba will say if you can't go forward again, you should know how to get back to where you're coming from. So if everything like gets if you get stuck at any point in time, this is your best place to come for help and ask, or you can ask Google, ask YouTube, ask anywhere. Just get help for yourself. All right. So this is where you can create new projects, open projects, save your projects, layout. The layout I showed you on ArcMap just now. This is it here. And you can just explore, can explore the ribbon, right? Can explore the ribbon. These are tools to show statistics, to measure line, to make inquiry, and all that. So guys, yeah. So first thing I would advise you to do when you get to your QGIS or on any software at all is to always set your spatial reference, to set your coordinate system. So for QGIS, please come to this space. This space you're seeing is EPSG. You click on it, just left click on it. So you won't see this here if you have not worked on it recently. So you can just, if you are working in Lagos, and we know it's just zone 31 north. You can write 31 north and come to this place to select the one that is applicable to you. So don't forget we're working with Google Earth imagery and we work with Google Earth work with WGS 84. And we intentionally put our Google Earth imagery yesterday. We conditioned it to UTM zone, right? So we decided to use UTM yesterday, and yeah, that's all we click here. UTM, you can click apply, then okay. So now you can see that the coordinate system has been set to the coordinate system we want to use. This is the coordinate system we have our data in. Then yeah, so we are assuming that we have downloaded our data from Google Earth Pro, and the next thing we want to do is bring in the data. So we look for georeferencing, georeferencer. So come to georeferencer, click on georeferencer. The georeferencer tab will open. So this is the georeferencer tab, and you click on let me see the name, open raster. You click on open raster, you get the imagery you want to work with. Excuse me, please. You open the image. So I've georeferenced this already. So yeah, we'll look for the one we have not. So I think I have another image there, copied it out. So this is another one. Okay, so this particular one has not been georeferenced, So if you work on QGIS, I would need you to listen carefully. So quickly, let me tell you that QGIS is not any lesser than ArcMap or ArcGIS Pro. I mean, they just have different functions, and but they can achieve the same results under different circumstances here. So if you have plugins, coding plugins, can do exactly what ArcGISPro can do, and you can even automate better. I mean, for automation, QGIS would be more preferable than ArcMap. It might not be compared to ArcGISPro because that's on another level, right? But yeah, so I'm just saying one of the issues when I was in ND1 at the Federal School of Surveying, the system I had could only get QGIS for some certain reasons then, and I felt like I'm behind. I don't want to use it. I was discouraged. I just left it. I didn't learn anything they were teaching us because every person was using ArcMap, and I thought I was not getting it. I wished I had just settled with what I had. Maybe I would have known more than them and all that. But yeah, I'm encouraging you. If you have QGIS, you are not lesser than the people using ArcMap or ArcGIS Pro. You can make do what you have. And I'm serious. QGIS is sweet. QGIS is sweet, especially if you want to learn coding and start automating your projects. Right. So we are on Georeferencer. We've added our raster. So automatically you have the this thing on. Excuse me, please. I have code, so you can just bear with me today, right? So you left click on the tip of the pane, and then don't forget we have downloaded, we have saved our data in a notepad. So you copy out Eastern's coordinate, paste it on the Eastern's tab, then you look for the Northern's coordinate, paste it on the Northern's tab. So the first problem you would have is if you do not arrange your data in a way you will understand. Imagine this is point one. Imagine I'm inputting the coordinate of point two to point one, and see that problem already exists. So here too, if it's not on default, you have to choose the coordinate system you are working on. You have to choose the coordinate system you're working on and click OK. So point one has been marked. All right. So the next is to go to point two. The next is to go to point two. And for point two, we'll do the same. We'll do the same. Copy things, paste on the right star, over copy nothings. Paste. So I'm using Control C to copy, Control V to paste. Okay. I'll go to point three. I'll go to point three. I'll highlight, Control C to copy, Control V to paste, nothings, Control C, Control V. All right, and now scroll to the fourth point, things. So if you can see, I labeled my points so that I'm not doubting which one is point one, which one is point two. Okay, and okay. All right. So don't forget at every point you ensure that the projection is correct. You choose the right projection for each. So yeah. So we just like finished imputing our coordinates. Yeah, come to transformation settings. Ensure that your projection is right. Insert where you want your output to go to, and you click OK. And you click OK. Click OK. And then you go and press this play button. It means start georeferencing. Start georeferencing. So you click on start georeferencing. And it will georeference itself. So we have toggled on that whenever it is done through georeferencing, it should open the image on the main tab. So we are good with this guy. GCP point, you can just discard. And yes, this is our georeferenced image. Again, how do we know that georeferencing has been done? Coordinates will have been attached to everywhere on this image. So if it was not georeferenced, you might be seeing, can you see the coordinates here? Might be seeing maybe minus or something here, but this is Eastern's, Northern's, and if you have if you have a GPS, you can put maybe an Android GPS or something. and pick a point on this image now. Say this corner, see the coordinates there. If you go there live and pick a coordinate point to, it must give you something close. Why I said something close is because we are using a DGPS, of course. You might have a discrepancy in say in some centimeters, right? If you're using handheld, you might have up to like 3 meters thereabouts, because especially if you are using your phone. Handheld is always handheld, produced for navigation, not for surveying. Can you guys hear me, please? Are we together? Can you hear me?
Yes, sir.
Are we to, okay, okay, thank you very much. Okay, so yeah, we have just georeferenced this image. We have just georeferenced this image. I just georeferenced this image. So the next thing to do is to um is to digitize. Is to digitize. So for us to digitize, we are going to be using our toggle editing. This is the tool we are using. But before then, we have to create layers. So on in ArcMap, we can create find your database, and on QGIS, you can create new geo package layer. You can package everything inside one layer. But for now, let's just create a new shapefile. So just come create layer, go to new shapefile, click on new shapefile. So you are going to name it what you want to create. So in ArcMap, it is called future class, and in QGIS, it is straightly called shapefile. So the future class actually are shapefiles. You understand? They are shapefiles. So straight away they call it shapefiles here. So we are saying you are doing buildings, and you create the geometry points. Like I said, depending on what you want to use it for. So we'll put buildings as polygons here. Also, you come and, like you can see here now, it then automatically puts our reference system. So we'll have to click on the reference system, the projection we are working on. So we have clicked our projection. This field now is the attribute data. You can add as many as you want. So yesterday we were adding name to the attribute, and the type is string, is text, and we can say add. And since it's building, we can say area, and the type would be float, decimal. So for here it is decimal. In ArcMap, ArcGIS Pro, it is float. In a standard um, SQL, it is called float. You're working on an SQL, it is called float. That means decimal, and we can click add. So we can add as many attributes to the building data we want to create, as much as we want. So once we are done with all of that, we click on OK. The layer already exists. Okay, so in the same document I'm working on, I mean, on that the same file on my local computer, I'd already created a building and all of that. So I'm just making a one. So yeah, this our shapefile has been created. Also, we'll create another shapefile. We'll call it road. We'll call it road. The geometric going to be 9. Then don't forget your reference system, very important. You can just like put name, and put name, strings, you can put length, you can put length, length will still be decimal, and add, I mean, you can add as many attribute data as you want. And once you're done, you can just press OK. And so we have roads. We can also like add rivers, create layer. So we can call this river. So I was explaining yesterday that there are different types of roads. So don't get it twisted when you see major road, minor roads. Yeah. So river, we can have the name. So we can have name. I didn't continue. So we've all had all of that, and yeah, this is where we are now. Are we together to this stage? Are we together to this stage? Responses, are we together to this stage?
Yes.
Thank you. The next thing is to start digitizing. So you come to toggle editing, and you click it. So toggle editing is on. This is the tab here. There's the tab here. So can toggle it on, toggle it off. Then add line. So um so say it's outside the current map view. Le, 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 le. Le, le, le. Okay, so I'm going to digitize the rivers first. Okay. So so go to toggle editing. You want to digitize our river. So don't forget once when you're digitizing as you can see it. So some people digitize at the center, which is most advisable. Digitize at the center. Some digitize the edges. So most advisable digitize the center, right? How many of you guys have QGIS in your system? How many of you have QGIS in your system?
I have it.
Okay, Sherry plus. Osakwe, okay, Jibril. Okay, Jibril also. So can you guys open? Okay, Isaiah, you do not. Isaiah, what software do you have? Which of these GIS softwares do you have?
I don't have any.
Okay. Do you have a personal computer?
Yes.
So why have you not installed?
No, it's not actually my computer, so I'm actually sharing with someone. So the person is not always
Oh,
around.
oh, okay. Right. So I would advise that you just install maybe QGIS for a start and practice anytime the person is around. It will help you. So
Okay.
I'm taking my time to digitize this so that you can apply the same principle to every every other one you're going to do. So depending on the accuracy, it might not require to make it this smooth. But my principle is always, I mean, if I'm required the higher accuracy, so I'll calm down more than this. Whatever is worth doing at all, believe me, is worth doing well. Okay, so yeah, take your time, and there is no way you tell me that a river is straight. It's not possible, bro. You didn't do it. You didn't do it. If a river is actually straight, you can't join. You can't join one line or two and tell me that river is straight. So don't forget, we didn't put name to the attribute table. So once you finish editing, it will bring out the things that are on the attribute so that you can describe the line that you just finished. Since this is our first river, I just put one on the ID and I click OK. And I click OK. So should we do one more river? One more river, one more river, one more river, guys. Okay. So all of this is water. So if you notice, one of the things you should always do when you get an imagery is to notice the color of the natural features. So this on this now you have your vegetation as green. Thick vegetation will be deep green, and your water is black. Water is black. So anywhere you see like a black part, you know that you're looking at water right there. And one of the things that I didn't mention too is that your your map should have a boundary. So your map should have a boundary. So it's part of the feature class. Oh yeah, feature class or shapefile you need to create is the boundary to your line so that we expect that no line should be isolated. It must either be originating from a boundary or be originating from another line, right? So yeah, that is it. So yeah, I'm going to nail this. This ID will be soon. So you can like just do this one also. Thank you, Jesus. One more. Code is eventually not a great thing. So so anytime I'm through with my editing, I just like right click and it will bring out the um, attributes table for me to fill. So yeah, we are done with that. We can like save layer edit, okay, and like pick road, toggle editing. So we now want to like work on road. So I think I'll leave you to work on road. Let's move ahead and toggle editing for buildings. So you can see that anyone I want to like edit, I'll just like click it on my layer tab, then toggle the editing and start. So yeah, for QGIS, for ArcMap yesterday we used points for our buildings, but for QGIS now um we are using this thing for polygon for our building. So you click on um you right click and it will tell you to put in the attributes data. So the name of the building. So please don't quote me. I'm assuming that this is VC's office just because I want to give you the name. Because if I'm like working on this data, if I don't know the name of this building yet, I can leave it open. Now I don't know the area, but if you get there, we are like going to calculate the area of each of the building, right? So I'll press OK. So you can see that I can leave any of the attribute information that I don't have yet. I can leave it open, right? So who knows the name of this building? Anybody? I don't. So I can't even say if you are right or wrong. I just like the architecture. That's why I'm asking. Is it your Senate? Is it where? Nobody? Okay. So these are second building. Let's say, excuse me, please. Just a minute. All right, guys. So sorry about that. So sorry about that. So let's call the name of this building Senate. All right. So we can go on and on, and so what we are going to do is this is our area, and you have to like you have to edit, digitize all the buildings here. Then once you're done with digitizing, you come and save layer edit. Come and save layer edit, right? So yeah, that is that. So let's try to create one more layer and call it boundary. Boundary. Don't forget the geometric type will be polygon. You have to set the reference system. Then I don't think we will need to add field, but yeah, we have it there. Boundary. We have boundary. And let's digitize our boundary, right? Let's digitize our boundary. So so that your this is online. You are not wondering where is this line coming from? Where is it going to? So if there is a boundary, you can tell that it's the line is terminating on the boundary, right? So yeah, this is it. So what happened here now is that our boundary is ahead of our image. So I put the image on top of the boundary. If I put the image here, so what we do now is to double click and come to symbology. Okay, so on the symbology, we can like put just outline. We can change the color. Normally now, surveyors we use like red for our boundaries. So I'll save symbols. No, not save symbols there. Okay, so yeah, so um this is the attributes you know. So yeah. Ooh. 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 So click apply or okay. All right, so we see that it has like given us just outline. So we can now, once you want to like edit this road, you can start it from here. So let's say you are editing road, we go on and click it. You can start it from the boundary and edit it to just the boundary. So just to say, mention that this thing is not archaic and is not old school. I still last year I still got a job just to digitize some stuff for an established government or establishment. And yeah, I collect my money. It was small, but I collected it. Mm. So yeah, so that's it, guys. That's it. That's the purpose of your boundary, so that your design can have a sketch. You can, I mean, can have a layout, right? So another thing we need to take notice of is our field. Um, so for this road now, this is the road we just entered, and it's telling us that it is 20 meters in length. We had another one that done that is 80. So that's what that will do for you almost immediately. So for let me check for buildings. I'm double clicking on the buildings, right? Um, all right, so yeah, so you can repeat the process and digitize everything that is here. I think that is what is in your assignment. So with what we've done now, you can use either QGIS or ArcMap to georeference. Of course, get your image from Google Earth Pro. Use QGIS or ArcMap to georeference and digitize, and of course, you can present with it. And also, you can present the data you have with ArcGIS Pro and present the data you have with ArcGIS Pro. Oh, oh, yeah, 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 yeah. This is the layout section, guys. This is the layout section. So you have to make some settings. You know, enter. If you have a template, you can enter your template. And all that you can edit. This is where you present your data. This is where you present your data. You can choose either A4, A3, whichever one works for you, landscape. So I took that on, I just right clicked on the page and I choose page properties, and you insert you open your map, bring in your map here, and you do your design, put text, put legend as you deem fit. All right. So um like I said, we can also present in ArcGIS Pro. I think that's what I will go to ArcGIS and do for you guys. So we'll be switching to ArcGIS Pro. We have barely 30 minutes to go so that we can learn on the ArcGIS Pro too. But before I conclude or assume that we've been able to introduce you to QGIS, I would want to know if you have a question. I would want to know if you have a question. I want to know if you have a question. Maybe on QGIS, maybe on ArcMap. You can't ask me on ArcGIS Pro yet because I'm not taking you there. But yeah, if you have a question in advance on ArcGIS Pro, you can also let me know. So please shoot. Please shoot. I do not have I do not have the I don't have too many energy today. You guys can notice here. So please just unmute and tell me if you have a question. If you don't, you can put it in the chat box. I don't. If you do, put your question there. If you like us to hear your voice, come on, talk to us. So I won't continue until I hear at least one person speak. That would tell me that you're following what I'm doing. Because without you following what I'm doing, I don't know what I'm doing. All right, guys. So please let me hear from you. Let me hear from you. Who is speaking first? Are we just here to mark attendance or something? Who is speaking first? Oh, thank you, Jesus. Thank you. Timilade, are you there?
Yes, I am. I don't have a question.
No question from you, Abby.
Yes.
All right. So it means you understood everything we have said about in QGIS.
I think I do.
Okay. Have you been using QGIS before? Dimilade, have you been using QGIS before?
Yes, but more of ArcGIS.
Or more of ArcGIS? But with the little you've done in QGIS today, you think you can shoot it right away, right?
Yes, I think I can.
All right. Thank you. All right. Any other person wants to contribute before we move to ArcGIS Pro? Okay, guys. We'll move straight to ArcGIS Pro. Okay, move straight to ArcGIS Pro, and I'll just go open my ArcGIS suite. This is my ArcGIS pack. I have ArcGIS, and then I'll click on ArcGIS Pro. So ArcGIS Pro, like I said, usually works all the time with your internet. So you have to have your internet on for you to use ArcGIS Pro. And it's also a paid software, which means that you have to have access. So either an organizational access or a personal access or a student access. I mean, you must have access, right? So, but yeah, I said we are in Nigeria. Things get. So I'm using ArcGIS Pro, right? But you can get there's a way to get a free a free access to ArcGIS Pro too. There's a way to get it, and maybe for the people that successfully have their certificate, maybe it's one of the things that we'll put on the board for them. It's one of the icing we'll put on their certificate. We'll give them access to a free ArcGIS Pro, right? So, and with it, you can do virtually anything that the paid version will do, right? So, yeah. Okay, so let's be patient. It's loading. They are the works of me. You are the only one. Oh, thank you. All right. So yeah, guys, welcome to ArcGIS Pro. Come to ArcGIS Pro. So when you open your ArcGIS Pro, you download from when you open your ArcGIS Pro, first thing you are required to do is to sign in. To ArcGIS online. So do you have anybody here that's taken any of the Esri MOOC courses before? Taking any of the Esri MOOC courses? Taking any of the Esri MOOC courses? Anybody? Okay, so if you have interest in GIS, that's like Jubril, do you want to say something, or you're taking one? All right, good. So if you have interest in GIS, you should explore Esri MOOC courses. You should. So Esri MOOC will like give you free access into ArcGIS online for the time period that you're on the course, and also it will require that you, before you even see all of this page, first page you see is that you sign in. I'm signed in. I mean, that's why. So you'll be required to sign in and all of that. So yeah, you can work with templates and all of that, but you can continue without a template. Can continue without a template. Don't forget, I said ArcGIS Pro works with your internet access. So when it's getting slow, might be first your internet, might be the processor of your PC, might be anything. So you just have to be patient. You gotta be patient. But I'm still counting my blessings. How about it is in my life? Woo! Okay, we are waiting, guys. So this is ArcMap. Let's quickly explore ArcMap. This is the map. So another thing that is peculiar in ArcMap is that it has an inbuilt base map. I'll show you. It has an inbuilt base map. It means that you can see everything you're doing on a base map. You can see everything you're doing on a base map. So it makes your work, your analysis, everything very, very easy. To be honest, ArcMap is sweet. ArcMap is the future, and we are here in the future. So this is a topographic base map. As a surveyor, you already know what topographic is all about. So let's give it time to move. So you already see this is a topographic base map. And we have all of the continents represented. So we go to where we belong. We will go to where we belong. We're in Nigeria. Nigeria, Nigeria. So this is a base map that has been is inbuilt in ArcMap. So let's explore. This is like this is the title area, and this is where you have your undo, redo, save projects, open projects, new projects. This is our ribbon. This is our ribbon, and each one of them has. So for project, you can like save your project, save as click on map, click on catalog. So map, these are base maps, like this is catalog, this is global scene, and this is our local scene. Right? If you're working with 3D, we want to like work with the 3D data, we need probably global scene or local scenes, right? So that's that about projects. Then we move to map. For map, we can explore. If I click on this explore, I can toggle, I can move. I mean, by just clicking one place, I can move right, left, center. It's just like a virtual map, a virtual mouse. All right, that's what explore is. Then I can zoom to extent, I can fix zoom and all that. Then full extent. Then I can bookmark. I can bookmark. So if I'm working in say Lagos, I can move bookmark it and move to Kano. If I click my bookmark, it will like take me back to where I was, just like the way you bookmark on your browser, right? Chrome and other browsers, as it were. Then go to XY. So if I have a coordinate, say of the VC's office, you can literally just like click on the coordinates and it will take me there straight. And if I have something to do around there, I can quickly just do it. Then we have base map. We have base map. So we have a lot of base maps in here. We have the topographic, in which we are using at the moment. We have navigation. So depending on what you want to achieve, what you want to do, you can change your base map as necessary, right? And change your base map as necessary. Then we have the add data. Add data is where we can add shapefile, add other data for analysis. You can even add an image, can add whatever data you need, and add graphics layer. Select, this is our query option. You can query your data by this selection. This literally works for your attributes data. Then you can measure, you can locate, you can convert coordinates. I mean, this is a whole lot. And you can also download a map. Can download a map. So moving on to insert. Is that what we have here? You can, I mean, you can plot layout, the same layout, guys. This is the toolbox. Don't forget, toolbox is one of the most important things because it contains all of your analysis and all that. So you can import map, can do a lot, can explore these guys. Analysis. Yes. Look at the toolbox in here again. So, and for analysis, I mean, it is what it is. You can do a lot of analysis with ArcGISPro, like a lot, a lot. Excuse me, guys. When we talk about 3D data, I mean, they function so well on ArcGISPro, right? So, yeah, ask that about analysis. Then the view and the view tab. So in QGIS, I was telling you how that you can automate your task by adding plugins and all of that. This is just an inbuilt Python window that you can go straight and use it to write a couple of code to automate or to process your data, right? So yeah, edit, create, modify, yeah, editing. So if you are going to digitize on this, editing will be there for us to help us. imagery share helps, right? So guys, are we good before we continue? Then okay. This person wants to talk. Honorio de pardon. Do you want to say something? And then Ajo.
Oh, no. Sorry. It was an accident. Sorry.
Okay. All right. So moving on, guys, we can add data. So we are going to add a shape file. It has already been downloaded. Almighty God. Almighty God. Men and brethren of Lagos, this is the boundary of your state. This is the boundary of your state. Was download. Okay, so yeah, I also promised that I'm going to mention. Please, somebody should remind me. I promised yesterday to give you sites where you can get free data, like open source. Of course, you already know about Google Earth Pro. Yeah, and so please, somebody should just remind me before we leave this class. All right. So this is boundary of Lagos, right? So we are going to um, okay. So I double clicked on it. It's giving me the symbology, and I'm clicking just black outline so that we can see what is inside, what is inside, what is inside, what is inside. You guys are following me, right? Yeah, so we have Lagos. Let us try to um I'm just trying to navigate to where our data is, right? So thinking of, we have just few minutes to go. So I'm thinking of what we can do with what we have. Okay, let's try to load this imagery. The imagery is about 17 gig on its own, so it will take a while. But I want us to do an analysis, please, even if it is just one. So if we are able to load the imagery, we are going to clip out an area out of that imagery so that we can touch that. I think that's the only aspect we have not touched since we started analysis, right? If we can just like clip out an area from that imagery, would have achieved something. So yeah, it's loading. Let's just give it time. It doesn't, it will not take all of our time. So like I said, the data is about 17 gig. So I personally do not expect that it will load quickly. But I think it's one of the best shots that we have at analyzing what else can we do? Okay, please just be patient. This is the data we are trying to load. You can see that 16.9 gig. Yes, it's crazy. And that's the kind of data we work with in GIS, right? So they're always huge. This is like um it's like somebody's project, and this folder alone is for this is 30 gig. This one I've sent it to the owner. I mean, we just work with crazy data in here. Oh yeah, let it roll. So we have barely 15 minutes, and let me state that we would have done more today, but since the first day, I don't know, we we had a good turnout on the first day, and people relented, and we are not getting feedbacks from you guys. I just hope that you guys make the most of these tutorials, and especially the 100 level students. I'm sure in subsequent times we'll want to dive into greater matter 300, 400, 500 level students will benefit more. But yeah, this is the beginner stage, because we understand that you guys just got into the profession, and you're trying to find your feet. I mean, 100 level, you are not even sure if surveying is still what you want to do, and all of that. And that is why all of these basics are very important. And to be honest, if I were you, I would still, even if I'd like laid my hands on one or two before, there is this deceit of us telling ourselves that we know, but knowledge is progressive. Knowledge is progressive, to be honest. And yeah, this is me just appreciating everyone who has been committed to this training from the beginning till now. And I think I'll cancel this guy because stressing me. I have 15 minutes, less than 15 minutes to leave here. So, uh, okay. So let's see if we can try. Do we have it? Is it coming? It didn't finish loading. Okay, let me see if we can get something else to. Okay, so this is the image we were using, and yeah, it's just a small portion of Lagos. I wanted us to like clip out an area in here, but obviously we can't do that. Can't do that with this. So yeah, basically, Sha, you you add your data. If let me still check if I have should be somewhere in Ibadan. I will make Jesus proud. Amen. Nations are waiting. People are hungry. The master exchange me to have paid my allegiance to the one who taught me. So this is the shapefile of the whole country. Is the shapefile of the whole country. I can also make this available. Or I say what I wanted us to do is to, and you can see it is like lapping um, on the base map, like exactly on the base map is not shifting and all that. That's because ArcGIS Pro has been stationed to um, program to like accept shapefiles, and it will work with the coordinate system of the shapefile you're bringing straightforward. And if you also notice, we didn't have to like do so many projection in here, right? Because like I said, this is it's an amazing software that you should explore actually. So what we are trying to do, if you have like a raster data around here, say around Gobe or say in Oyo, and this one has been personally we have excuse me, let me check something. We splitted this some time ago because we needed the states to appear to appear on their own. So say we have a raster data, an imagery of a whole state. And by the way, there are still like shape files of the local government and all that. So we have the shape file, say, of an whole state, and you want to like clip out. I said shape file. If you have a raster data, an imagery of an whole state, and you want to like clip out a portion of that state, so we just like use the clip tool and clip that portion out. I think I'll just explain that without okay, so this is this is like the shapefile of the whole country. This one is still one state. One state is still on. One state is still it should be on. Yeah, one state is still okay, so quickly. Okay, so this is shapefile, complete shapefile of the whole country, right? So say where is it? So we can like come here and right click and go to attribute data. So this is the attribute data of the of this spatial data. So don't forget to say spatial is the one that has the XYZ, and the attribute is the description of the spatial data, right? So this is, if you like click here, it must highlight it on the map. So here we are clicking Ekiti, and Ekiti is telling us that it's a state, and yeah, so this particular shapefile is comprising of the all states, and we have another. Let me see. Excuse me. In this should be more details. So okay, so let me open the attribute data for this. Okay, so this one like has the local government. So this is Aba South. Can just click where Aba South is. Who can tell me which local government does your school falls under? This is Aba South. Your school is in which local government, please?
Yaba.
Yaba. Thank you. So first thing we look for is Lagos. So look for Lagos. Look for Lagos. We have Skidi. We can query. We can query and it will bring out Lagos State for us. But let me just manually quickly explain what I'm trying to do. Okay, so we are in Lagos. This is Lagos, guys. So what we need to look for now is Yaba LGA. Okay, this is Agege. This is Ajerome, Alisha, Apapa, Efe, Etiosa, Bejuloki, Keja, Busofe, Milan, Mushin, Ojo, Shudi. Okay, so are you sure there is Yaba local government in Lagos? Your area is Yaba, right? But the local government area.
I think mainland local government.
All right. Okay, so we can like click on mainland. Okay, so this is where we will find so if we have an imagery that has like the whole of Lagos and want to work on this particular part, we just like use this to extract oh, thank you, Jesus. So you can use these tools to extract the raster data. So if the image I was loading, if we add it, so this clip raster, it means that we'll tell ArcGISPro that it should use this vector, this particular boundary. We'd have to clip out this first. We'll impute the raster. If we have the, say we have the whole imagery, I mean this one didn't load correctly, and it's even an imagery in Kaduna. It's an imagery of Kaduna, so it won't work. So let's say this is a raster image, then we would like have to insert the this thing we want to use. Say This one is an imagery of the old Nigeria. We want to extract Lagos. So we are using the Lagos shapefile to clip. So this is like the output extent. So this is like the output data set. The name will give the output. And yes, so once we are sure everything is correct, we just click on run. Of course, it is not correct now because this is like imagery of Kaduna and we didn't even wait to load it. We had to remove it. So, I mean, this is, if you run this now, it will clip out Lagos out of the entire state and say you have Lagos. Let me check Lagos too. So say you have Lagos and this is mainland. All right, in the whole of Lagos, this is you have an imagery. Assume that your imagery is all of this, Lagos that is outlined, and you want to clip out mainland. So you just pick in Lagos, the raster of Lagos here. You put in the shapefile of mainland, and you just run it. Of course, determine the name and the output folder you want your the output of this clip to save on, and you click on run. It will extract the raster of just mainland out for you, and you can easily just make your other analysis on it. So for example, another analysis we can do that will work well is, say we want to okay, we can even talk. So we have a base map now, and we are saying this is Alaba. This is Alaba. Alaba is a residential area, all right? And of course, we can see that Alaba has a lot of Apapa, Ajegule. They have a lot of closeness to the water bodies around, right? I want to buffer that. If this water part now, when when the raining season gets to its peak, what is the possibility of these water plants affecting this settlement, Ajegule settlement, and how can we solve that problem? How can we solve that problem? First thing we want to ask is, what is the proficiency, what is the closeness, proximity of this water body to this environment? Is there a smooth passage? If there will be a spillover of water, if water wants to make its way and all of that, are people living close to the river? Will it affect them? So we can like buffer, say, give me all the houses that exist. Give me all the houses that exist. Okay, so this is the buffering tool. So you can say we have to input the futures. We have to input the output class. If it is output future class, will be telling us, are you expecting to get a line? Are you expecting to get a polygon? Do you understand? So distance of field. So I'm saying, give me every houses that exists in between, say, 50 meters radius. So if I put 50 meters here and I run site type round, I'm saying it should measure on a radius. Okay, so if I run this analysis now, I'm saying it should bring out every houses that exist between 50-meter radius, it will run a round circle that is exactly 50 meters and bring out all the houses that are there. By that, you can say, oh, we want to create a water channel around this place, and the water channel is about, say, 30 meters wide. All right, and of course we'll need to give offset of, like, say, 10 meter, and any house that like appears around our 60 meters walkway around the water course, around the drainage you want to create, would have to demolish and probably pay compensation. Instead of going house to house, house to house, house to house, they can just run this analysis on the map. Of course, we'll still go and see, we call it ground truthing. You still go for ground truthing to see if what you have on your imagery is true, is the same with what you have on ground. So you can, like, after you've run your analysis, which will drastically reduce your stress. So say you see like 20 houses on the left, you see 50 houses on the right, and you go on ground, you might like see probably one, you are seeing a fine house at the time the imagery you're using is being taken, and when you got there, probably the house has been demolished and all of that. And of course, when you're using these kind of tools to make analysis, you try as much as possible to use features that are permanent. Houses, you don't use like cars, things that can move. Do you get? You use you don't even use kiosk, because kiosk might not be there when you go there tomorrow and all of that. So you try as much as possible to use features that are permanent and all that. So I mean, that's what buffering is all about. I think so. Yeah, it's 1 o'clock, and I think I would stop here. I would stop here for today, and I'm sure this is like the most interesting part. I wish that data opened so that you guys can see more in ArcGIS Pro. ArcGIS Pro is actually sweet. We can have a 6 hours study on it, and we won't exhaust ourselves. We won't exhaust what we have to learn there. It's so amazing, and it's really really good for automation and for analysis. So if you are not laid your hands on ArcGIS Pro, please get something doing with it, right? So I don't know. I think you guys should have questions about ArcGIS Pro. So let me wait and see if you have questions. If you don't, we'll call it a day. If you don't, we'll call it a day. So ArcGIS Pro, do you have any question? Any question? Any question? Any question? Any question? Any question? Any questions at all? All right, please go ahead.
What does the buffering do again?
The buffering.
Yes.
The buffering tool is a tool that is used to analyze what is around an area. Is used to answer a particular question you might have in your mind. Sure you get. So say we have, for to explain a simple layman term, right? Say at the University of Lagos, you have a particular okay, let's not use University of Lagos. Say in Maiduguri, there is an outbreak in an area called Azu, an outbreak of malaria. Do you understand? And it was discovered that everybody in Azu community in Maiduguri, this is just an imaginary name, it doesn't exist, so don't think about it. So everybody in Azu community in Maiduguri are recently having malaria, and probably they are dying from malaria. All right. So we can say that, oh, we want to take interventions to Maiduguri, to Azu community, but if we just approach or attack this disease in Maiduguri, in Azu community, there's every tendency that somebody has moved from another community to Azu community at the time being of the outbreak, and probably has contacted and has gone back to his or her town. So instead of just focusing on Azu community in Maiduguri, let us see and approach it to everybody that lives in, say, 500 meters radius from that community, and let us give the intervention to every household that appears within the 500 meters radius around that community, instead of just giving the community, because it's of course expected that people that are close to the community will have come there to trade, probably contact the disease, take it back to their state. So instead of us going to like putting tape on ground and say measure from this angle, don't forget we are talking about radius. Radius means we are measuring around the community. Take your own tape from this place, measure 500. We can come on, get a very recent data, download it. There are satellites, though they might be paid, there are satellites that gives like up to 1 day. You can have your informations updated up to 1 day. Do you understand? 24 hours to be specific. So, and there are some that are even less. So you can like get that kind of imagery and say, buffer tool, I need every houses that exist that appears between 500 meter radius from Azure community. So don't forget, for you to achieve that, like I showed you on the buffering tool, you input the input raster, which is like the imagery, and I believe you have clicked out to specifically Azure community. So you clip in the imagery of, put in the imagery of Azure community and tell the buffering to measure on the distance, to measure 500 meters. You put it to round, which is the radius, and run the tool. So the tool will like bring out a circle, and more like a blue circle that will randomly show, that will circle all the buildings that is within that radius. All right, and that you can say, oh, this building, this building. So you now take the results that you have and take it to the physical ground to go and do what we call ground truthing. So you go to do ground truthing, is just checking for a fact that the result you got on your analysis is as true as it is on ground. So of course, most of the time, if you're not using a recent data, a recent imagery, you might get discrepancies, but of course, you have saved you a lot of stress having to count one, when you're going with an existing fact. Might not be fact, but you have an information to work with depending on how recent your data is. And if you're working with a very recent data, of course, you can even have it all checked out. So that is a good brief explanation of what buffering can do and more. So I don't know if I've answered your question. Who asked the question? Are you clear now?
Yes, sir.
Ben, thank you. All right. Who else is asking? So this is, if there are no other questions, before we call it a day, I'm behind schedule, to be honest. I have another meeting for 2 that I have to prepare for. So we are behind. This is like the layout. This is the layout. This is the layout page. So this particular layout, I picked A4, and just like it is on ArcMap, all right, you can always like add, can bring in, don't forget, I mean, we didn't really work on anything yet. So if we have our this thing already, we have our map produced already, we'll bring it out. This is the map page, this is the layout page. We'll bring it out on the layout, all right, and we add our notes, our row, add our scale, add everything that you need to add here. And I want to tell you for a fact, you can do whatever you have done on ArcMap, do it on QGIS, and just bring it here to present. Presentation of ArcGIS Pro is always very beautiful. I don't I don't know, but I think the artistic template that exists on ArcGIS Pro is up to standard. So it makes your work very, very neat and looks a lot professional to what you just go and design on ArcMap. And of course, you can always bring in your topo, your base map too. You can cut a part of your base map to be part of your presentation on ArcGIS Pro, right? So yeah, guys, with all of that being said, this will be the end of our training. And just to recap, that to mention that everything we have done is just the basics. There is more, there's a lot more to everything we talked about, from AutoCAD to software to QGIS to ArcMap, now to ArcGIS Pro. There is a lot more that you can do with these softwares, and they are really, really interesting. But our passion, our aim for this 2 weeks tutorial is to get you started, is to introduce you to the interface, to introduce you to the basic tools, and get you questioning things. And in GIS, the person I grew under, my boss always tells me that what makes you progress, what makes you better, are questions in your heart. You just have to question things. It is when you question things that you look for ways you can use GIS to solve it. And don't you ever forget that GIS is not the software, it's never the software. The software is just part of the component that makes GIS. For you to get the complete GIS, you have to have all the 5 components, which is the hardware, the software, the method, the people, and the others, and the others. Like I think I've just mentioned 4. There are 5: the hardware, the software, the data, very, very important, the methods, and the people. All right. So guys, keep learning, keep growing. I sincerely want to appreciate the leadership of the NIGS, of University of Lagos, for giving us this opportunity to impact you guys. Like I said, I'm promising that we'll make the link available